Hey guys, welcome to brainAttic. So today we have another very interesting problem from the topic of integrals. Now this question was asked in JEE Advanced 2015, and the questions like these make the exam all the more difficult because it is not the difficulty of the problem in itself, but the time you should consume to solve this problem is what it makes a real challenge. Now, if you do want to give it a try, you may pause the video now and give it a try. Otherwise, we can continue solving the problem. In this question, we are asked for what values of a and L does the equation where we have two integrals, one in the numerator and one in the denominator, is equal to a certain value, which again we have to identify. Okay, so this question is one or more than one options type of a question. So there is a fundamental concept which I would like to tell you before we start solving the problem. Let us assume we have a y is equal to sin x kind of a wave. Okay, now the wave looks, let me redraw this, sorry. Now the wave looks something of this nature, and I would like to tell you that if you're taking the sum of the area which is inside here, let me first mark the x values. So if you're taking the sum of the areas which is under this which is under this area under the curve is almost equal to the area under the curve from 2 pi to 3 pi. A similar conclusion can be made if you're taking an area under the curve from pi to 2 pi, it will be equal to from the region from 3 pi to 4 pi, provided the equation is only like this and there are no changes in the argument of the sign. Okay, so if we see that in the equation, let me say I'll define a new variable I1 and I'll only take the numerator of the problem which is there. So it is given from range 0 to 4 pi e power t sine power 6 at plus cos power 4 at dt. So this is my numerator term. What I'm going to do is I'm going to split it into parts. So I'm going to take the first integral from 0 to pi. I'll rewrite this expression. Again, I'll take the next integral from pi to 2 pi. The next integral will be from 2 pi to 3 pi. And finally, we have the integral from 3 pi to 4 pi. So what I have done in this step is basically I have written down this integral which was from 0 to 4 pi as a sum of four integrals, each which are on the period from which have a period of pi only. Okay, so 0 to pi, pi to 2 pi, 2 pi to 3 pi, and 3 pi to 4 pi. Now, what I'm going to do is I'm going to define them as I2, I3, I4, and I5. Now, the reason for doing this is if you look at the denominator, my denominator is only having an integral from 0 to pi. So, when you have enough practice and you can identify the problems, right, this gives you a hint. When you look at a problem, there is a certain hint which is there, which you have to identify. So, when I look at the problem, I saw that my denominator is ranging from 0 to pi. So, why not I go ahead and split this integral? So, when I'm done, I have this kind of a expression. So I'll not touch I2 for now, but I'll take I3. And my integral I3 is given by pi to 2 pi e power t sine power 6 at plus cos power 4 at dt. Okay. So if you see here, I'm going to apply variable substitution and I'm going to substitute t with pi plus x. And this gives me that dt is also equal to dx and my new range for the integral will be from 0 to pi. Just a simple substitution of the range values for t and you can see that the x is from 0. If you apply 2 to 2 pi to t value, then you will see that x goes to x. So if t is equal to 2 pi, x is equal to pi, and if t is equal to pi, x is equal to 0. So I got my range values and t over here will become pi plus x and sine power 6 at, right? If you apply pi plus x, it will remain the same. if you follow this graph over here, right, it will still remain the same. It will not change. Plus, if any magnitude difference is there, we see that the even powers in the expression. So magnitude changes are also taken care of. Therefore, I can again write this as sine 680, sine power 680 plus cos power 480. Sorry, my mistake. Let me write this as 6ax plus cos power 4ax dx. If I take the term outside e power pi, then I have 0 to pi e power x sine power 6ax plus cos power 4ax dx. And we know that the variable doesn't matter when you're taking an integral. So this expression over here is exactly as I2. Therefore, I can write that I3 is equal to e power pi I2. Okay. Now I'll just go ahead and show you for I4 as well. Now in I4 we have 2 pi to 3 pi e power t sine power 6 at plus cos power 4 at dt. Okay, now what I'm going to do, I'm going to define the variable t as 2 pi plus x, and this gives me that dt is equal to dx. And when you apply the value of t as 2 pi, when t is equal to 2 pi, x is equal to 0, and when t is equal to, let me just, t is equal to 3 pi, x is equal to pi. So this gives me that 0 to pi e power 2 pi plus x sine. Again, same logic. We are shifting the waveform by complete 2 pi and the waveform looks the same. And even if there is any magnitude change or order change, that is taken care by the even powers in the expression. My mistake again. Let me write this as ex and this is as ex as well. Dx. Yeah, correct. So I'll take this 2 pi term outside and what I have now is integral over 0 to pi e power x sine power 6ax plus cos power 4ax dx. Correct? Now this again, as we know, the variable over which you're taking the integral doesn't matter. In place of x you can have u, in place of x you can have t, in place of x you can have m, anything is fine. So this again resembles as I2 and what I have now is e power 2 pi I2. Similarly, when you go ahead and you solve it for I5, right, you will end up having something as e power 3 pi I2. Now going back to my equation, which is I1 I have found out to be I2 plus, instead of I3 I have e power pi I2, instead of I4 I have e power 2 pi I2, and instead of e power 5 I have e power 3 pi I2. So I'll take the term I2 common and what I am left with is 1 plus e pi plus e power 2 pi plus e power 3 pi. Now, if you see that my L is actually integral over 0 to 4 pi e power t sine power 6 at plus cos power 4 at, and the denominator was 0 to pi e power t sine power 6 at plus cos power 4 at. Now I have defined this expression as I2. Okay, I have defined this expression as I2, and this expression I have defined as I1, and I have found that I1 is equal to this expression over here. Okay, so this eventually gives me that L is equal to I2 1 plus e power pi plus e power 2 pi plus e power 3 pi by I2. So I2 cancel each other, and finally what I'm left with is 1 plus e pi plus e power 2 pi plus e power 3 pi. And this I can very well write it as e power 4 pi minus 1 by e power pi minus 1. So this is nothing but from your GP series. This is valid. The interesting part is this is valid for all values of a. So nowhere I was affected by the value of A, which is in the argument of sine or the argument of A cos. So if you see nowhere in the problem, right, the A value affected me. So if you jump back and see which all options are correct, right, and we do see that option A and option C are correct. So if you do like the video, hit the like button, subscribe to our channel for more content like this. Thank you so much for watching.